So here all we're doing is making sure that the target bubble is where it needs to be inside the bullseye. Then we can go ahead and turn the unit on. And once we start to rotate here to send out our signal, we'll get an indicator up here if we're out of level. If we're out of level, then the unit won't work. So I'll go ahead and throw it out of level. You can see it start flashing right there. Now we're not going to send the signal, so we'll just adjust back. And we have no red indicator, so that means we can go ahead and send our signal. So here's our receiver for our laser plane. It has tone, so we can hear it when we're out in the field. Fast tone means that we need to lower the receiver, and a slow tone needs me raise the receiver. And then if we get an even tone, that means that we are level between the receiver and the sending unit. So all we do is use this as a quick check to check, say in this case, the top of the leveling nuts for the steel. So we could go around. This is a pretty good instrument. We can shoot hundreds and hundreds of feet. We can check elevation changes in the ground. And if we're trying to hit grade in a certain way, we can check top of a concrete footer. Great little units, not a whole lot to them. Sends out a signal, receives the signal, and tells us whether we're high or low.
So what we're doing is we're preparing to set a column. Before we do that, we have to adjust the nut on our anchor bolts to the proper elevation. So since we've already set 3 columns, we can utilize the elevation of the bottom plate or the bottom of the plate of one of our columns. And when we set our stick to that elevation, then we can transfer the elevation over here to our new anchor bolts and adjust the nut in the proper direction so that this column will set at the same elevation as the other 3. What we would have done prior to this, if we were out in the field, is we would have brought a level loop and transferred a benchmark onto the site close to where we're working. And we can assign that an elevation. Okay, and then we would continue around and we would close the loop to make sure that we were accurate at all of our points that we established elevation at. So once we bring that benchmark onto the site, then we can use our laser level to do the rest of the work so that we can put our instrument away and work off of one benchmark for the job and the foundation.
So we could shoot back from our laser to the benchmark, set the receiver, and then carry through, in this case, to our leveling nut and get all those at least established close before we set our columns.
Right. So the elevation, the whole idea of bringing the benchmark in is to assign an elevation to that. Because on our blueprints, all of these anchor bolts and the nuts, where in essence, where the bottom of the base plate of the column sits, has an assigned elevation to it per the prints. If we didn't have that, then we wouldn't know how the structure, the elevation of the structure is going to be built with regard to all of the underground, our storm, sanitary, sidewalks, parking lots. All of this civil work dictates at what elevation the building sits.
So whereas in wood construction, we'll be using some pre-cut cuts, things like that. But in the case of a large commercial building, anything with this heavy steel in it, this steel would have been being built prior to the project really getting started. So we have to hit those marks.
Right. Everything's to a determined length, width, size. Everything's determined by the designers. And when we fabricate a structure in steel, it's not like wood. We can't just run back to Menards or Lowe's and buy a 2x4. if their error in where we place the building and how level the building is can just stop the show, because what it means is we have to have everything refabbed, or at least the problem parts.
Because this is all pre-engineered out.
Pre-engineered.
So if it comes out and we have missed the marks on our anchor bolts, you're not just cutting off the end of the steel because it was 3 inches too long. Everything has to be run back through the engineer and make sure
Right.
that it's all still going to work.
We can't take it over to the saw, put it on it, and cut it. They don't like, engineers that is, don't like us to do any real fabrication on the steel in the field. They want it under those manufacturing parameters where everything's a little more exact. When we field build, we tend to have a little more error.
Sure.
Something else is if we, when we're close, some guys will try to elongate bolt holes and stuff to slide steel and whatnot. This creates a problem because anytime you apply heat to this steel enough through an oxyacetylene torch, it's going to start to temper the steel. So what is tempering the steel? It makes it very strong in that, but very brittle. So we've screwed with the structural continuity of our steel. Now, does it happen in the field? Yes, a little bit they'll live with. But if we make it an industry standard or a best practice, we're really diminishing the design of the structure.
Sure. So we'd have our receiver set. We'd come off of our benchmark, or in this case, we came off the existing bottom of
Right.
plate or top of leveling nut, and we went ahead and shot the top of these 2 leveling nuts and got a solid tone, which means we were balanced out where we
We're
needed
good.
to be. So we were good to go. These are great little devices, as we talked about before. Usually our only issue is when we get somebody that stands between the sender and the receiver. Don't be that person.
right.
And I don't know why it's not reading, boss. Check your body position and make sure that you've got a clear line of sight to the receiver.
The difference between the dumpy level that you guys can refer to in the level loop, the differential leveling segments, the difference between that optics and the laser is the laser's fairly accurate up to about 400 feet with this spectrophysics. We can shoot within a quarter to an eighth, or an eighth to a quarter of an inch. Of course, if we're using the optics, we can get it right almost perfect.
Sure.
So the laser, we do sacrifice a little bit of accuracy, but the best practice for that is not to get but a couple hundred feet away from the transmitter, so that you can kind of minimize that.
Yeah, and
so
if
if we can be within a 1/16 of an inch of getting this steel structure in place, we're doing pretty good.
Right. And if we're out shooting rough grade,
Perfect.
perfect, because we're not down
Yeah,
to
absolutely.
this tiny little increment.
And when you watch people digging in the dirt and they're getting down in their excavation, you're going to see a stick man down in the bottom that's going to be seeing what the
Giving them
elevation is. at the
spot
bottom, right.
elevations
Spot
as they go.
checks. We use the laser a lot when we do any grade work for road work, for when we're putting in the sub base for our foundation. Everything. This is something you'll see on every job site today, at least commercially.
Sure. And thinking about what might be used on site, this is not really a laser that we have to be extremely careful with as far as any safety issues with vision. There are lasers
Yeah,
out on site
absolutely.
that we'd have to be concerned with.
This laser, the infrared light that it produces is detrimental with prolonged exposure. So what we don't want to do with this laser is put it at eye level, because if it's at eye level, you're going to catch it. Now, is it
Consistently,
going to
yeah.
burn your retina or anything like that? No, but like I said, prolonged exposure can do some damage. So we do want to take some precautions. There are special glasses you can wear when you're using lasers that block that infrared, all those bandwidth that's detrimental to our eyesight. We can wear glasses, shielding. This isn't too bad, but there are, as you get up in the ones that'll project further, get a little stronger beam.
Sure.
And you just want to be mindful, keep it down so it's not up at the eye level.